Okay. Please, Heather, can you confirm that we are on YouTube? Yes, we are ready. Okay, welcome everybody. This is a pleasure to be here. Thank you to put in the chat. We have two different chats. This chat is to participate, and we have other chat of question and answer in the middle of the presentation. If you have some question, please put your question in the chat of question and answer, that we don't lose any question of you. And when we finish this presentation, we will have some time to start to make some questions that Dan or ourselves, we can answer all your inquiries. Okay, please, Dan, can you introduce yourself and say hello to everybody?
Hello, everyone. My name is Dan Miller. Another thing I would like to see everyone put in chat is uh, what was your purpose for attending today? Whether you are from lithium-ion battery manufacturing, or you manufacture other products with lithium-ion batteries in them, or you're just a user, a recycler of lithium-ion batteries, or maybe a firefighter or a fire protection company that has clients that could be using lithium-ion batteries. So kind of want to know why you came, what industry you're from, what your purpose is, so that we can better inform you on what your needs are. Um, as Hernan said, my name is Dan Miller. I am uh, the Chief Training Officer for Hazard Control Technologies. I'm located here in Atlanta, Georgia. This is where our agent is manufactured and where our headquarters is at. And we've been in business here since 1997, but we do business globally, and we have a distribution network from around the world. Um, we've conducted over 15 years of fire testing specifically on lithium-ion batteries with great success, and it's a wide concern all over the world, and probably one of the leading fire concerns technologically as the world moves forward towards more green energy. Um, Myself, I have 40 plus years of experience in the municipal fire service, including small cities, rural areas, large municipal class cities as well. I was a battalion chief for Omaha, Nebraska Fire Department and chief of training there. I was also a fire chief in Columbus, Nebraska, and I'm retired from the fire service now, but I am the Chief Training Officer for Hazard Control Technologies as well as the product manager. So I'm going to start by talking a little bit about lithium-ion battery technology in general. We're going to keep things very general here. There are several different chemistries involved in lithium-ion battery manufacturing now. Uh, and but basically, a lithium-ion battery is a rechargeable battery in which lithium ions move from the negative electrode to the positive electrode during discharge and then back when charging. They're popular due to their energy density. They have a lot of energy for their size and their mass. They have minimal memory effect, which means their charge is more effective through more life cycles or more charging cycles. And they have a low self discharge. So when they're sitting around not being used, they don't discharge uh, hardly at all. But they do discharge over time. The old lead acid batteries, they discharge just sitting around. Lithium ion batteries don't typically have that problem, whether they're trying to engineer that out of them as much as possible. But there are three major components or layers to a lithium ion battery in general. And one is the anode or negative side of the battery. The other is the cathode or positive side of the battery. And then in between it is a layer called the solid electrolyte interface or SEI. So that SEI is a thin, semi-permeable layer called the passivation layer that forms on the anode surface during the first few charging cycles, and it acts as a barrier. It's a thin, solid layer formed uh, uh, that kind of like cellophane That's kind of what I imagine it like, but it's part chemical, part physical, and it lets the lithiated ions travel in one direction, but not the other one very easily. um, it's created during the initial charging cycle when the electrolyte decomposes due to the electromechanical reactions in the anode. So the SEI consists of both organic and inorganic components, including lithiated salts, lithiated oxides, and polyolefins. So it's kind of a plastic consistency as it's formed on the battery surface, on the anode surface specifically. And the ionic conductivity across the SEI allows the passage of lithiated ions while blocking the flow of electrons, ensuring the battery's ability to charge and discharge. A life cycle, a well-formed, stable SEI is crucial for the long-term performance and life cycle or number of charges of a lithium-ion battery. So, as engineering and technology has moved forward, the SEI layers have become better over time, and the ability for a battery to last longer through a larger number of life cycles is the result. And the SEI also helps to prevent internal short circuits between the anode and the cathode, and which would otherwise cause thermal runaway inside of the battery. So a good SEI layer enhances the battery safety as well. So in general, the formation of a stable and uniform SEI can be challenging, especially under extreme operating conditions like vibration, shock being dropped, like portable tool batteries or automotive batteries going down the road, hitting bumps and chuckles and things like that. That's hard on the batteries. So a good solid SEI layer that also resists things like overcharging and other types of trauma, water intrusion, etc., is important. Researchers are always actively working to improve the SEI layer with new electrolyte additives, surface modifications, and other techniques to make sure the batteries perform better and better over time. But lithium ion batteries do fail in several modes. Number one is short circuiting, either internally between the anode and cathode because maybe it got punctured by something or penetrated or bent or creased. But somehow that trauma caused a short circuit. It could be an external short circuit because of uh, a short circuit between a positive bus bar and a negative bus bar, a positive wire and a negative wire, for example. Trauma, drops, and damage can trigger instability in between, chemically and physically in between the layers. Overcharging can lead to batteries overheating, and extreme temperatures can as well. Hot and cold temperatures, age, dendrites can form in between the layers, kind of like stalactites and stalagmites, and eventually they touch. And then you have a short circuit and a thermal runaway inside of the battery, or maybe just a dead battery that won't take a charge anymore. So we've probably all heard a lot about thermal runaway. Thermal runaway is when a battery uh, goes into a degradation chain reaction, causes a lot of heat, a lot of vapors to be emitted, and eventually, usually flames. But there are two types of thermal runaway in lithium ion batteries in general. One is non-flaming combustion or a vapor only thermal runaway. And then there's flaming combustion as well as part of thermal runaway. And then there's the in between where it can just do a vapor only thermal runaway for a while and then it finds an ignition source or it gets hot enough internally to cause flaming. So some of the hazards as a result include vapor cloud explosion. Vapor cloud explosion is a primary hazard of lithium ion battery thermal runaway, and it always has to be taken into consideration as we're looking at fire protection systems for lithium ion batteries, as well as firefighters are approaching a lithium ion battery fire situation, such as an EV inside of a garage where they don't have good visibility and those vapors might be confined. Lithium-ion batteries have a very common effect called the blowtorch effect. The blowtorch effect flames result from flaming thermal runaway, and those blowtorch effect flames can reach up to 10 to 15 meters at times and catch other ordinary combustibles on fire, and then cause the fire to grow and spread rapidly. Projectile hazards, especially from lithium-ion batteries that are made from cylindrical architectural type lithium-ion batteries, those become projectiles at some point, a lot of times in a thermal runaway event, and escape whatever container they're in, can fly around the room or area and catch other ordinary combustibles on fire, as well as be a projectile hazard to persons in the area. So battery construction, state of charge, and final use, what kind of package it's distributed in. You see the package there on the image on the screen. The state of charge, final use has a lot to do with the outcome of the thermal runaway. This little video is going to show, oops, click on it correctly. It's going to show number one, a vapor only or non-flaming thermal runaway. If this were in a confined area, you can imagine how fast it would fill that confined area with these volatile organic compounds in an airborne form that once they find an ignition source could become very explosive. So the primary hazard here is a vapor cloud explosion, or VCE, you might hear us refer to it as. This is flaming thermal runaway. So this battery is going to go into flaming combustion pretty early. You can see the blowtorch effect flames there. The bigger the battery and the more batteries that are in that package, typically the larger that blowtorch effect flame will reach. And then the greater the number of cells that are in there, the more projectile hazards you have, and the greater the fire spread opportunity. So the big thing there to take away is that we have to protect against any of these various outcomes. We can't have a system that we're counting on for public safety be only based on flaming thermal runaway or a closed head system. And we can't only have it focused on a vapor only event. It's got to cover any event resulting from that thermal runaway. So we look at the overall risk of lithium-ion battery thermal runaway events. Number one, the lithium-ion batteries are everywhere in society now, and that is growing every day. There are more lithium-ion battery manufacturing facilities being built in every country every day. And just the volume of those batteries going out the door and being included in anything that you can imagine, that's growing each and every day. So that opportunity for thermal runaway events is going to continue to increase. So we have to get some type of a handle on how we're going to deal with it as a hazard. And it's really no different than when gasoline-powered automobiles were invented. That was a new hazard when they were invented. So there's hazards to all technological advances. There's a lot of material diversity in lithium-ion batteries. So each battery contains multi-class materials based on the battery chemistry, architecture, and type. And because of that, we can't focus our efforts on only one or two types of battery chemistries. We have to have a solution that's universal to all. And if you think of a parking garage, every vehicle that pulls in there from a different manufacturer could have a different battery chemistry involved in the batteries that are in that vehicle. So you have to have a suppression system that will cover all the bases. Toxicity, these batteries emit dozens of toxic gases that cause acute respiratory distress in humans, and obviously cause smoke inhalation issues, rapid and acute trauma in people, and keep people from being able to escape. And then the energy they contain, The stored energy is at high density. Even though one or two cells may burn and go into thermal runaway and degrade, it doesn't mean the entire battery is dead. So if you look at a battery is really a series of cells. The individual things that you may have called a battery growing up are really just a cell. When we group them together, it's called a battery. So typically there's a number of cells in any battery. You wipe out one or two, it doesn't mean the whole thing is gone. There's still a lot of stored energy there. So the real cost of battery fires come down to the life safety hazards they pose, the potential for catastrophic loss, environmental damage from the thermal runaway that we see, and not only the thermal runaway, but the consequential fires that result, the entire structures and facilities and buildings that burn down, recycling centers, etc. Those all put off typically a very large cloud or plume. And all those clouds of emissions, they go somewhere and they don't just disappear. They land on things, they become fallout and they're contamination. And then as firefighters or fire protection systems rain down on these fires, there's runoff potential as well and environmental damage from the runoff itself. Some other risks and losses included in the cost of battery fires include the cost of damage to your reputation as an industry and a business, whether it's a manufacturer, an end user, a recycling center. Your reputation can be largely damaged by a large fire that, maybe you guaranteed the community that you were going to operate safely, but one cell out of millions of good cells is all it takes to turn into a really bad situation. And then business continuity as well. When one cell goes bad and you have a thermal runaway and it costs you your business, it also costs a lot of people their jobs, and the local economy takes a big hit as well. Your ability to continue gaining revenue, your market position, your market share gets impacted by all of that. So many fire protection systems aren't equipped to protect the public, the workforce, or the infrastructure from lithium-ion battery hazards, and we need to get a better handle on that. So there are a lot of structural risks involved with the advent of lithium-ion batteries in everything we do. When I was fire chief, I went to my first lithium-ion battery fire 10 years ago. So it's been quite a while. But in the meantime, there were many, many fires that we associated with charging small device batteries that burnt down entire structures and cost people their homes and so forth. So, but modern combustibles, synthetics, adhesives, chemicals, lithium-ion batteries, and structures are a problem. And all of these relate back to the acute toxins, the ability for a fire to grow and spread through airborne contamination and proliferation of airborne fuels. A lot of the buildings that we respond to or that we cover as fire protection contractors are lightweight construction. So they have steel bar joist truss roofs, which collapse without warning. They have a lot of these buildings are, especially recycling facilities, manufacturing facilities, very large footprint buildings, which creates a problem from the point of distance to egress and just the size of the airspace available to a fire to grow. Lightweight steel construction, if it's not appropriately protected by suppression systems, we can run into a problem with building collapse. The compromised atmosphere, the explosive off-gassing, the toxic off-gassing, and then the limited visibility that creates for people to escape that environment. And that's true not only in production facilities and things like that, but if you consider parking garages, I know of a lot of lithium-ion batteries, and I know of at least one hospital that had a significant lithium-ion battery event occur on a cart where batteries were charging. You think about the ability to evacuate everyone from a hospital or something like that. it's a big problem with that limited visibility and the toxic off-gassing. Volatile environments cause early fire spread, faster flashover, limited egress time. I know of one recent fire here in the US where egress time was maybe 90 to 120 seconds before the entire very, very large building was consumed on the interior. So, limited egress time as a result of lithium ion batteries, their intensity, and the corresponding design of the building and fire suppression systems, they can have a big impact, negative impact. But we're seeing lithium ion batteries in every walk of life and every part of society now, no matter where you're from. So the personal mobility devices, material handling equipment in warehouses and factories, individual vehicles charging either at your home or residence or in group environments like in a parking garage, over the road heavy transportation, in manufacturing of goods that we consume and use every day, the recycling industry, battery energy storage on the grid at the grid level, and as well battery energy storage in single family dwellings and apartment buildings. And then as cargo in transportation, a lot of lithium ion batteries being transported around the world. So what we're going to talk about next is what HCT is known for. HCT is known for the production of a product called F500 encapsulator agent. An F500 encapsulator agent is a water additive. And because it's a water additive, it's very scalable to any size incident from the smallest to the largest. If I can get the sound to go here.
The next generation of fire and hazard mitigation. First, we start with a simplified version of a single encapsulator agent molecule consisting of a hydrophilic polar head which loves water, dissolves in water, and a hydrophobic nonpolar tail which fears water and will do anything to get away from water. Once the EA molecules enter the water, they instantaneously and automatically orient with the nonpolar tails inward and the polar heads outward, forming millions of spherical micelles. Micelles travel towards and exit the nozzles, forming EA droplets. Micelles nearest to the surface of each droplet automatically break apart. The nonpolar tails orient outside the droplet with polar heads on the surface, forming an EA skin on the surface of every droplet. In addition to the EA skin, there are millions of molecular spherical micelles within each droplet.
So what you're seeing here is a cutaway of a water droplet. That blue layer is the outside of the water droplet. The things on the surface are individual F500 molecules with the polar head pointing inward towards the water because they like water, and the nonpolar tails pointing out away from the water because they fear water. Inside of each water droplet, as the video said, there's millions of these spherical micelles. They look like little golf balls in the picture, but trapped inside of each of those spherical micelles are available carbons and hydrocarbons that were in the atmosphere or were part of maybe a liquid fuel or electrolytes that were in the battery in this case. So as the F500 impacts those materials, either airborne or otherwise, it encapsulates those carbons and hydrocarbons and it isolates them from oxygen. Once we isolate that fuel from the oxygen, you eliminate the possibility of combustion. Some other features of this water droplet that make it more effective than plain water is the surfactant capabilities of F500 make each water droplet able to be much smaller. So that breakdown of the surface tension of the water, allowing smaller water droplets, means much, much more surface area available to heat absorption, as well as the actual coating on each water droplet makes it resistant to vaporization and ununiform absorption of heat. So it makes it absorb heat more uniformly, more readily, almost with 100% efficiency as compared to plain water, which is less than 10% efficient at heat absorption. So it's very efficient at absorbing heat into each individual droplet, highly effective, anywhere from 10 to 30 times greater efficiency at absorbing heat than plain water droplet because of these different features. And then that water droplet is also has a high molecular weight. So as it comes out of something like a deluge head or a sprinkler head, it has a greater ability to penetrate thermal columns and other things that might block it from reaching its target. So encapsulator agents help us mitigate modern hazards. An encapsulator agent is not a foam. It's the opposite of foam. What does a foam do? A foam sits on top. A foam sits physically on top of the fuel and tries to smother it by isolating the vapor space from the fuel itself. F500 does that on a molecular basis, but it does it very, very instantaneously as it strikes the fuel and it intermixes with the fuel. And then it cools very, very rapidly as well. So unlike a foam, which works on the mechanical level to separate the fuel from the oxygen, encapsulator reagents work on that molecular level, and that reduces flammability, explosivity, which is something that's very unique to a fire suppression agent, and toxicity. F500 works on all four legs of the fire tetrahedron and simultaneously removes heat. It interrupts free radical coalescence. Free radical coalescence, anytime that you have incomplete combustion, which is almost all combustion on Earth, unless it's in some kind of a lab and in some special chamber, is incomplete combustion. So with incomplete combustion, you have a release of free radicals. Those free radicals are seeking balance. Because they're unstable. And when they find each other and they coalesce or come back together, they form volatile organic compounds, things like hydrogen cyanide, carbon monoxide, benzene, all kinds of really, really bad stuff for us as human beings. But those are also buoyant airborne fuels that causes the fire to grow and spread rapidly. So anytime we can interrupt those free radicals from coming together, it interrupts the creation of those volatile organic compounds in the air. F500 is PFAS free. It always has been. PFAS works to separate. We don't want F500 to be separate. We want it to mix. So having PFAS in our product would make it not work. So it has no PFAS in it. Encapsulator agents, interestingly enough, now, when we're talking about lithium-ion batteries and their proliferation, the airline industry, airports, etc., are becoming more and more an area where lithium-ion batteries are growing in use every day in airport ground support equipment, people in parking garages in the airport, personal devices used in and around the airports, and even aircraft. And then whatever people carry onto the aircraft typically has some lithium-ion batteries in it as well. Recently in South Korea, you may remember a news story where you saw an aircraft like this one on the slide with the top burned off of it because luckily they were on the ground, but somebody brought something on board. It went into thermal runaway, took over the cabin of the aircraft very quickly and burn it up. Luckily, the people were all able to escape. But the last FAA circular AC 150/5210-6C allows encapsulator agents now to be used on the airport grounds as a complementary firefighting agent. The other thing that F500 does very, very well, it acts as an agent to improve health, safety, and survival. So when we're talking about public safety, civilians, firefighters, or anyone associated with thermal runaway, when you have F500 involved in that initial application on the fire, it's going to improve survival, health, and safety. F500 has undergone many, many tests over the last 25 to 27 years, including a university study in 2006 by Clemson University, which showed a 98.6% reduction in toxic emissions when introduced over a toluene rubber fire. Toluene rubber puts off some pretty nasty materials normally. This took out 98.6% of those. In Laval, Canada, in 2022, a study showed a reduction of about an average of about 70% of polycyclic aromatic hydrocarbon accumulation on firefighters' personal protective equipment when they used it for initial attack on a structure fire. And then an organization called A Plus in 2024 did a study, a test of F500 on an EV fire in their tunnel as a test for effectiveness. And what they found was that it maintained a clear, visible, and survivable path of escape for occupants of that simulated structure. So when F500 is applied early, especially initially, it allows an improvement in health, safety, and survival of any occupants, whether they may be public or firefighters in that space. F500EA is documented as PFAS-free over many tests over many years, but one of those is by a company called SGS, a very large organization that covers many, many countries and has thousands of employees, does lots of testing. NFPA 18A is an NFPA standard on water additives for fire protection and vapor control. And it's the first of its kind that covers encapsulator agents. There's a test within NFPA 18A called Section 7.7. It's called the Spherical Micelle Stability Test. That evaluates a water additive agent's ability to be classified as an encapsulator agent. And then Annex 4.3 of that same standard references the ability of encapsulator agents in extensive third-party testing for many years to be successful at lithium-ion battery fire suppression, as well as the encapsulation of flammable electrolytes and the reduction of explosive and toxic vapors. So that testing demonstrates the ability to stop thermal runaway propagation. Again, that testing has been by many, many third-party organizations from around the world since 2008. So some of the points to make here about F500 is that it does both explosive and toxic vapor suppression. It's very prolific at that. As soon as it's applied at the right rate, it's going to knock those vapors down, bring a product down below its explosive range, and enable survival. It's NFPA 18 compliant. It improves life safety and survivability, and it maximizes infrastructure protection too, because it's a great cooling agent. Many of the other agents out there might handle, one part or another of the hazard of lithium-ion batteries, but one of the things that they struggle to do as well as F500 is cooling and infrastructure protection. So F500 really excels at that. Explosivity, how is it mitigated? F500 quickly encapsulates the explosive off gases emitted by burning lithium-ion batteries, things like hydrogen, methane, carbon monoxide. F500 simultaneously cools the materials as well and blocks that free radical coalescence from forming those volatile organic compounds in the air, which both spread the fire and become toxins and become explosive if it's a vapor only thermal runaway. So it really handles the bulk of the hazards of lithium-ion battery by simple application. It's especially important while extinguishing the lithium-ion battery fires within the enclosed environments, because that's where they become explosive. So if you look at things like parking garages, data centers, aircraft cabins, energy storage systems, it really helps us improve survivability, reduce loss, and overcome that explosivity and toxic vapor production. Flammability, F500 is very efficient on lithium-ion battery fire extinguishment because it does get in between the cells and the layers of the cells. If those cells open up at all and F500 is applied, it gets in there and encapsulates those flammable electrolytes. We've got NFPA section 18A section 7.7 testing specifically on those electrolytes, and it shows that it does that job. F500 successfully halts that cell-to-cell ignition, also known as thermal runaway propagation. Inside of a cell, thermal runaway from layer to layer, it's really hard to stop because it happens very instantaneously and causes that cell to get hot and basically self-destruct within seconds once it occurs. But that propagation from cell to cell, that F500 moving through those spaces really cools very rapidly and blocks that from moving on and becoming that endless chain reaction. F500 provides long-term stable burn back resistance. Again, that's because it does get into those layers inside of those batteries. Once they start to split apart or come apart, that F500 is able to get in there, penetrate, neutralize those electrolytes, and cool rapidly. How's the toxicity mitigated? Again, it's by encapsulation and blocking that free radical coalescence. So F500 reduces the concentration of toxic off-gassing produced during lithium-ion battery fires, including hydrogen fluoride, which is very toxic, carbon monoxide, and carbon dioxide, and other things. There's a whole rainbow of toxic gases that come off of lithium-ion batteries, almost all of which are carbons and hydrocarbons, which F500 is very good at encapsulating. So we talked a little bit about A+ laboratories. So in Madrid, Spain in 2023, our HCT's diamond doser fire protection system with F500 EA was tested at their large facility in what they call their test tunnel. So what we found with that, and this talks a little bit about A+, they have over 26,000 employees, 70 countries, very large organization, doing testing, inspection, and certification. And many of their tests are recognized by UL Solutions in many countries as well. Here's the test configuration, though. You can see that overall tunnel. They put in a deluge sprinkler system, 2 automobiles, and a 3-space parking garage. The center vehicle, or the vehicle in the center spot, had a 50 kilowatt hour lithium-ion battery. The one next to it's a typical ICE internal combustion engine vehicle. Although the temperatures reached a height of 244 degrees Celsius or 471 degrees Fahrenheit, before extinguishment began in this test, the adjacent vehicle, the little green car on the right, that vehicle only suffered minor burn damage to the paint and one side mirror. So a few other things about this test. To achieve success in this test, there had to be 4 critical parameters met. The evacuation corridor, or that third space that was left open around the automobiles, that corridor temperature had to remain below 60 degrees Celsius, and it did, or 140 degrees Fahrenheit. So it had to remain a survivable space, and that had to be 1.5 meters from the car. Closer to that, it could be a little warmer than that, but 1.5 meters away from that car, where the ability to escape and get around that problem, get away from it, was maintained throughout. The temperature of the slab had to be lower and remain lower than 150 degrees Celsius or 300 degrees Fahrenheit. The fire could not spread to the adjacent vehicle, and it did not. And the detection temperatures, 2.5 meters from the ceiling, could not exceed 70 degrees Celsius or 160 degrees Fahrenheit prior to activation, and they did not. Because of this test and its success, F500 is now, along with the diamond doser, part of an internationally certified system under ETI-2055 under A+, or what that refers to as conforming to this test or that big long TR number there. But it's a certified system, and it's actually been applied in Madrid, Spain, in a large municipal metropolitan bus depot where all of those buses are EV buses and they charge, and it's protected by one of these systems. A little bit more about the test. So part of this is the system had to activate by the time the temperatures reached 160 degrees Celsius at the ceiling. They actually let it burn for quite a while to get into thermal runaway, and then they manually activated it. But the indication was that it would activate before that. And that was a test of the detectors themselves. So they had 100% containment after 20 minutes and no spread to adjacent vehicles after 60 minutes. The test was designed around 60 minutes, but it didn't take near that long to get under control, remain under control, and maintain a survivable space for any occupants that might have been in that space. Allows plenty of time for firefighters to arrive and remain in control. So part of this system, if you look at some of the components that are involved in this system, it's a 3% application. We have Tyco D3 nozzles, 2 per parking space, a flow rate of 250 liters per minute, or only 66 gallons per minute. The extinguishing area in this test was 404 square feet, or 37.5 square meters. Sprinkler application density in this test was only 0.15. However, we recommend that when you're actually designing for this, you design the system to either the NFPA or FM requirements, and then add the F500 at 3% because it'll more than do the job. Working pressure was 43.5 PSI or 3 bar. The total water requirement was only 3,857 gallons, and that was for the entire 20-minute test of flow. And then the F500 EA requirement for that same time period was only 120 gallons total. Oh, excuse me, not 20 minutes, 60 minutes, excuse me. So if we reverse the math out of that, 60 minutes, 3% at 0.15 GPM per square foot, you come up with the total used was 120 gallons. So it doesn't take a lot of agent, but when you apply it in scale to a larger zone and a bigger parking structure, there has to be some math done, and it has to, meet standards for the entire covered area. So detection is a big part of this. We talked about explosivity and the ability for these batteries to go from nothing into a vapor producing thermal runaway for a period of time, and then maybe progressing into a flaming thermal runaway. But the one thing is, we don't have control over that. No one does. The batteries have control over that. The compartment size and the space has control over that. We don't really have control over the state of charge or anything else at the moment that this thermal runaway is going to occur. So detection is extremely important. So HCT has partnered with Embedded Logic, which makes a system called SmartAlex. SmartAlex is a condition monitoring platform that enables detection, prevention, and suppression. When paired with F500 encapsulator agent, it becomes that end-to-end solution that you need for situations like you see in the picture here, the best battery farm. Where we have lots of containers, lots of racks, lots of individual trays of batteries. We can detect down to the individual tray, the individual rack, the individual battery energy storage unit, and provide protection at all 3 of those levels as well. detecting that there's a problem very, very early and allowing us to shut it down is very important. But if it does go into thermal runaway, whether it's vapor producing or otherwise, we want to be able to apply F500 at the right level. So our system protects at the tray level in those battery racks, and then also has a head over the rack itself. And then there's the general one for the entire container as well. So it's a perfect system end to end for battery energy storage systems, data centers, parking garages, or any type of process hazard. It provides public safety and infrastructure protection throughout, and helps you protect not only things like your data centers where critical business is taking place, but also infrastructure, which is critical to public safety. This condition monitoring platform allows notifications to be sent to any connected device, worldwide, network-wide, cloud-wide. You can have optional triggering of any type of signaling devices in the area, as well as taking action with fire suppression systems themselves. So it makes notifications. It allows you to monitor things like temperature through their proprietary software, hotspots. It can be connected. It's legacy compatible to pretty much any kind of detector on the market, whether they're connected via SCADA, Ethernet, or wireless, etc. The most modern detection through thermal imaging, or the oldest detection through, very, very simple heat and smoke detectors or vibration sensors, you name it. It can be connected to almost anything. Very capable system. So some other testing we've done recently, manual firefighting, but to lead an entire country down the road of fire protection with F500 is we worked with the Fire Insurers Laboratories of Korea, or FILK. It was established in 1986 by the Korean Fire Protection Association. FILK is equipped with 400 kinds of state-of-the-art testing equipment and has more than 25 years of fire testing and research experience. Their laboratory is recognized by the American National Standards Institute. FILK was amongst the first fire labs in Asia to be accepted by the U.S. Coast Guard, the Russian Maritime Register of Shipping, and other shipping registers. So this video is going to show you some of the testing that we did with them.
On October 15th, 2024, F500 Encapsulator Agent was put to the ultimate test. The 2020 Hyundai Kona electric used contained 10 battery packs at 100% charge. Fire suppression was applied by an underbody water spraying system supplied by an outdoor hydrant. An F500 EA solution proved to absorb thermal energy 10 times faster than plain water or foam. This test took place at the KOLA S accredited Fire Insurers Laboratory of Korea. At 1420, it's time to demonstrate the effectiveness of F500 EA. Once an incipient fire forms, it'll be allowed to pre-burn for 7 to 10 minutes. Then, fire suppression will begin. First, we heat the battery with a torch to induce thermal runaway. Because the lithium-ion battery is located under the body, a flame is applied from below. Now, there's nothing to do but wait. As heat builds up, toxic fumes begin to fill the test environment. .5 minutes in, we see initial venting and the first thermal runway from the battery. Then, full-blown flames. With the removal of the gas torch, the fire's left to burn for up to 10 minutes, simulating a fire brigade's projected arrival time. "13 minutes into the test, and the fire has spread to the hood, rapidly engulfing the entire front end of the vehicle. Smoke starts to build as the seconds tick by. And as the battery continues to burn, the risk of additional explosions only increases. Soon, interior areas succumb to flames, which are now rapidly spreading to the passenger seats. Over 18 minutes into the test, the entire interior of the vehicle is engulfed. 1 minute later, a second thermal runway occurs. Seven minutes after the blaze's onset, the fire brigade's arrival signals the start of fire suppression. Beginning with the activation of the underbody spraying system, and quickly followed by a discharge of 3% solution of F500EA. To meet the unique challenges of battery fires, F500 Encapsulator agent tackles three distinct risks: flammability, explosivity, and toxicity. Unlike traditional foams, encapsulator agents work on a molecular level. As off-gas is expelled from the front end and flames emerge, F500EA quickly targets the origin of the fire. Already, high-temperature flames present on the interior and exterior of the vehicle are suppressed. Hazard Control Technology's next-generation fire suppression system affords a level of protection backed by over 15 years of independent, scientific testing. Just 8.5 minutes after the 3% solution of F500EA was discharged, fire suppression is complete.
This kind of fires is very hard to extinguish because it's the hazard of the explosion, the fluorine, hydrogen is very poison for the firefighter, for the people. The idea with this technology is how we can extinguish this faster than other agents and how we can protect the firefighter with less water. This additive work in the molecular level that you can encapsulate the toxin of the smoke. This is why you convert the black smoke in the white, like it's an steam, that you can prevent all this hydrogen explosion, all this toxicity that the people can breathe in the fire or the firefighter can breathe, and you decrease the toxicity of the smoke almost 98%. You prevent all these gases in the middle of the atmosphere, plus all these toxins and cancerogenic agents to prevent the cancer in the firefighters. Europe, in South Africa, Australia start to use in USA, the factory of Tesla car, they are using in the charge station. And more we test this, more we start to use in the real world. We start to use less water, less time, and we can protect more our people.
All right, so the big thing there is you look at the time, the figure on the bottom, 8 minutes and 30 seconds. Look at 901 gallons of solution completely used. And we were only flowing from that hand line less than 60 gallons per minute and about 70 gallons per minute from underneath. So combined, you're only looking at 120, 130 gallons per minute overall for 8 minutes. Not too bad. Not too bad. Really puts it back in the realm of a single fire engine and a single fire crew putting these things out. These are all organizations that have done testing for and with F500. So you got that Fire Insurance Laboratories of Korea, EPA, it's the EPA registered surface washing agent, FAA approval as a secondary agent. All these other agencies have a role in the success of F500 and in the recognition of its capabilities. So we've talked a little bit about a diamond doser. What is it? A diamond doser enables you to put F500, proportion F500 very, very accurately into sprinkler and deluge systems and even water mist systems. But this device basically goes in the riser. And yes, it's horizontal right now, and that's there for a reason, but we put a riser bypass into an existing riser, put this device in there. It basically has a water wheel on what you would call the left side in the waterway over here. And then on the right side, it's got a small piston pump that's accurately proportioning F500 into that riser. So wherever it goes, if it goes into a deluge zone, or it goes into an entire sprinkler system and then finds the open heads, or it goes to some other targeted use, it's there very accurately over a wide range. HCT is the sole distributor of the diamond doser in the US. So when we apply encapsulator agents, we're applying superior protection compared to plain water or any other agent. We mitigate multi-class fires, three-dimensional fires, vapor or explosivity, and the contamination and runoff hazards themselves. It's increased sustainability and it avoids unexpected discharges, pollution, and disposal costs when you add a dose and return valve into your diamond doser setup. Um, and we can talk about that anytime you want to. I won't go into that for interest of time, but basically you're not discharging agent for testing purposes. And when you do, F500 helps that runoff be more environmentally friendly. Minimal maintenance on a diamond doser compared to a bladder tank helps you save time and money on your investment. We have lots of models of the diamond doser, all the way from a 1.5 inch waterway up to 10-inch waterway and 10,000 liters per minute. These are all places, agencies, and organizations that have diamond dosers and F500 systems installed. So hopefully you've put some questions in the Q&A section or in the chat section. We can start answering some of those now. Hernan, if you can start.
Yes, we have done a lot of questions that we started to address. We tried to address in the chat, but we have one question in the question and answer is A500 is the only agent certified by NFPA to fight lithium batteries? I put in the chat the chronology of the lithium battery, and you explained that it's not only that's NFPA certified. In the annex, 8.4.3 explain that the additive that's passed the NFPA 18A section 77, the encapsulated agent that has different certification and tests like KIWA, DENCRA, different other tests, you can use on lithium batteries. In the chronology that we put, you will find a lot of these tests. But
Yes, so
there are no certification of the NFPA.
So it's a recognition that encapsulator agents in general, if they meet section 7.7, which makes them an encapsulator agent, have a high level of success in this testing. Well, the one thing we can say for sure is that F500 has the longest history and longest chronology of successful testing on lithium-ion batteries of any agent worldwide. And no one can compare to that. A lot of agents coming on the market now are doing testing, but none of them since 2008 except for F500. And really that passage, that Annex 4.3 was written around the work that had been done with F500. So that kind of hopefully answers that question.
See, you know that somebody put in the chat that how encapsulator agent work on lithium battery fires. There are some videos showing they are not fully effective. This is why I put the chronology. In the chronology, you will see some red buttons in the different tests that you can open the test and you can open the videos, that you can take a look, the real test that don't made by our company, made from the third-party labs. We have Abdul Rahman, that's, can we have the water or agent mix ready for use for years, or we need only to start the mixing during operation of discharge?
Okay, very good question. You can tank mix F500 for years in advance. Or you can proportion it at the time. I like to compare it to having bleeding control or CPR or an automatic defibrillator handy. If you don't have it available for initial use right away, then you're not going to be able to save a life with it. So I really like to promote either tank mixing or using it on every fire with the initial attack line. And if you're talking about a fire suppression system, the same thing. You really need to have it able to be proportioned in right away with a diamond doser, bladder tank, etc. But to answer the question, yes, you can tank mix it for years in advance. And I guarantee you, if you use it on all fires, you're going to really, really love its performance on structure fires, um, natural vegetation fires, you name it, it works very, very well.
Other question that Matia asked in the chat, and I answered him, is what temperature does the lithium battery reach in non-flamming event? And I explained that in non-flamming event, flamming thermal runaway event, a lithium battery can reach temperature between 248 Fahrenheit to 482 Fahrenheit, depending on the specific chemistry and conditions.
Okay. Yeah, again, there's a few different architectures of lithium-ion batteries, and then there are more and more different chemistries, and I would say hybrids of those chemistries as time goes by. So it really depends on that, and it also depends on state of charge. So
yes, and you need to know that around 176, 212, the electrolyte may start to break down, leading to gas generation. Around 240, 302, the separator can begin to shrink, increasing the risk of an internal short circuits, and in the temperature continue rising to 392 to 482. The thermal decomposition of the cathode material may occur, releasing additional heat and gases. This is why I put in the chat to explain.
And what's breaking down, that SEI layer is breaking down. So the anode and cathode are find themselves together all of a sudden, and you have thermal runaway.
Yes, Mustafa asks if it's already mixed, does it have any corrosion effects on the steel tanks or pipes?
No, it doesn't. It's pH neutral. There are certain types of gaskets and pure brass that it can react with a little bit if it just sits for a long, long period of time. But for most steel pipes, plastic tanks, PVC pipe, all that kind of stuff, it's going to be just fine in there.
Yeah, there are other questions that does this 500 system introduce agent with a sprinkler system similar to a foam proportional? It is currently listed approved for use in a sprinkler system.
So if I understand the question correctly, is it approved for a sprinkler system? And the answer is yes. It's a process of education. It's A and B listed under UL, under NFPA 18, so it can be operated through a sprinkler system, a proportioning system, similar to foam. We have F500 is very low viscosity compared to most foams. Most foams are very heavy and sludgy. F500 is more like motor oil. But it mixes and proportions in very, very well, very, very easily. And it actually kind of, it mixes itself because of the amphipathic molecules ferrying each other and ferrying water. It self-dilutes in water and stays proportioned very, very well. It doesn't settle out like a lot of foams might. So it's very applicable to being used in a a sprinkler system. And a lot of it comes down to really educating the authority having jurisdiction of what it is and that it is A and B UL listed and what it does. And then there are like, between that and the fact that it's PFAS free, and if you've looked at all at the performance capabilities between AFFF foam and fluorine-free foam, you'll know that it takes an average of about 3 to 4 times more fluorine-free foam to do the same job that AFFF did. And AFFF compared to F500's performance has always been weak. So one thing that F500 will do that AFFF or fluorine-free foam will not is it'll put out a 3-dimensional Class B fire. So spraying, cascading, flowing flammable liquids or gases, F500 will put it out, whereas AFFF will not, and fluorine-free foam will not, because it's not a pooled liquid. So it's extremely effective.
Yeah, you know, there are different questions in the chat that Ron with me, we start to address in the chat that all the people can see. One of the questions that Liz Morgan asks is, how does A500 different from coal fire? Also, an encapsulator agent that Ron explained. To be an encapsulator agent, you have to pass the NFPA 18A section 77. See, if you pass this test, you start to see that you are an encapsulator agent that Ron explained in the chat. Here in the question and answer, we have an anonymous. This is ACT pursuing possible factory mutual global approval of A500 as a factory mutual global fire protection as shim and water additive agent.
Okay, so typically factory mutual approves things for certain uses. Okay, so F500 has been approved by factory mutual in certain conditions for certain uses. And we continue to pursue testing as we have done over the last 25 years where it's most beneficial. As you know, UL and Factory Mutual both, are in the business for business and they charge for testing. And so we continue to pursue that testing as it's cost effective for us. If there are situations, however, like here's an example. At a power generating under turbine lube oil fire protection system, Factory Mutual was going to require this power plant to double the sprinkler density of their sprinkler fire protection system using plain water because they didn't think it was adequate. But we did some side-by-side testing with FM witness that F500 was able to very, very well control the fire at their current sprinkler density. And all they had to do was add F500 rather than double the capacity of their entire sprinkler system, save millions of dollars. Well, FM approved that, but they would only approve that for that site. So there are those kind of limitations that they operate. They operate a business for their purposes. We operate a business for ours. When we do a diamond doser system, or I should say a proportioning system, the components are FM approved, and the agent is UL listed for A and B fires. And typically that's good enough for some situations, but not every situation, and we recognize that.
Okay. We have the last three questions because we passed the time. Is Mustafa again is environmentally friendly, the A500?
Yes, F500, it's PFAS free, it's biodegradable. So what does end up getting, say it's runoff, for example, it actually encapsulates the carbons and hydrocarbons that are a part of the runoff and makes them more environmentally beneficial by encapsulating them in the spherical micelles, and then microbes in soil, for example, eat those microbes up and it's healthy for them. Whereas if it was just waterborne runoff, then you have water and you have the chemical and it doesn't encapsulate, it simply dilutes and spreads it out. Same with foam. You're adding to the contamination with foam. With F500, you're treating the runoff. And when we dilute it down far enough, it's absolutely sound to go through a wastewater treatment plant.
One of the last questions, can any proportional be used to proportion in 3% into a sprinkler system or only the diamond doser?
Diamond doser is just one that we promote because it's very friendly on your total cost of ownership. But we also use bladder tank systems, around the pump systems. Pretty much any way you've proportioned in the past will work.
Okay. And the last question is from Doug is, are there any code specification design criteria for using A500 to protect lithium-ion batteries?
Codes, there's not really a lot of codes addressing lithium-ion batteries other than electrical code and or the code for things like battery energy storage systems, which is more on how they're constructed, and not a lot. And it's about passive fire protection and things like that so far. As you know, lithium-ion batteries don't fall into a fire class under NFPA or any other organization. They're a standalone animal, a standalone beast. Because of the nature, they're not they're not really a Class A fire. They're not a Class B fire. They do have energy, and uh, they're not a Class D fire, a metals fire either. They're a mixture of many classes of fire trapped in a small container. But F500 attacks all of those mechanisms, and it's very, very effective at it. Um, we've never had in the 15 years of testing a situation that F500 applied appropriately won't overcome it very, very quickly.
And I know that we finished, but we have a wonderful question in this moment from Fernando. Is how does a 500 mix with Class A and Class B foam?
We actually
The
we
answer
sell
is
it
no.
a lot to fire departments for the purpose of replacing their A and B foam with a singular agent. So, but we don't encourage you, we actually discourage you to mix it with any existing foam concentrate without a good flushing or rinsing of the previous concentrate because we don't know the impacts or effects once it's mixed with somebody else's chemical that we don't know what it consists of. So, and there are a lot of different foams out there made of different products. And now that there's fluorine-free foams on the market, synthetic foams, we have no clue what's in those either. I can tell you that for sure. So when it does come to getting rid of PFAS out of existing systems, flushing typically doesn't work. But there are companies that do that try to get rid of it out of it. We know many companies end up replacing the entire plumbing in fixed suppression systems and replace entire fire trucks to get rid of PFAS.
Okay, thank you, Dan. I believe that we addressed all the questions. And for the people that ask, we will send the video that we are recording on YouTube. We are on live on YouTube. We will send maybe this week or the beginning of the next week an email with the information of this webinar with the link of the video that you can review or you can share with your colleagues. And I want to say thank you to be here, and please, Dan, you can say to everybody goodbye and Sam to be here all this hour.
Thank you guys for showing up at odd times and odd hours of the day and taking time away from your day. Be sure and check our website and our e-library. Look for the things that you need. And we have the ability to get a hold of us on there or ask for quotes on systems. So reach out. We're here.
Okay, thank you so much. Have a good day, have a good evening, and have a wonderful life. See you in the next webinar, and you can review in our website that you have all the webinar from the beginning of the year to the end of the year. Thank you so much, and